Defined as the agent of produce tends to produce destroy of this tends to destroy motion. Agree. A force while acting on the body, all of this above. In order to determine the effect of force acting on a body, we must know as all of this above. The unit of force in SI system is the newtons. 1 kg of force is equal to 9.81. A result force in a single force which produces the same effect produced by the all the forces acting on the body. True. The process of finding out of the resultant force is called of the forces composition. Algebraic sum of the resolved parts of the number of forces given direction is equal to the resolved part is the resultant in the same direction. This is known as the principle of resolution of sources. The vector method for the resultant force is called as the polygonal of forces. This is correct. The resultant of two forces P and Q acting on the angle theta is P square plus Q square plus 2PQ cos theta. If the resultant of two forces PQ acting on angle theta makes an angle force P, tan alpha equal Q sin theta by P plus Q cos theta. The resultant force PQ, P greater than Q along with the same straight line but the opposite direction given by P minus Q. The resultant of two equal forces P making an angle theta 2P cos theta by 2. The resultant of two forces equal P acting at a right angles is the root 2P. The angle of between two forces, then the resultant maximum and minimum respectively 0 degrees and 180 degrees. If the resultant of two equal forces has the same magnitude and either of the forces, then the angle between the two forces is the 120 degrees. The resultant of two forces PQ doubled the resultant of perpendicular to P is the Q is equal to R. If two forces are acting at an angle 120 degrees, this is the 20. The terms leverage and mechanical advantage compound have got the same meaning is the right. A number of forces acting on a point will be in equilibrium. Sum of resolved parts vertical direction 0, sigma v equal to 0. Sum of resolved in the horizontal direction 0, sigma h equal to 0. If the number of forces acting at a point, the resultant given by sigma v square plus sigma h square. And again, if figure two equal forces at angle at point force acting along the bisector in the opposite direction root 2p. Number of acting forces point resultant of the inclined angle theta, the horizontal such that tan theta sigma v by sigma h. This is the correct. The concurrent forces of those force lines of the action is the meet at one point. If the resultant of number of forces acting on a body is 0, then the body will not be the equilibrium is no. The forces which meet at one point and their action lies on the same plane is known as coplanar concurrent forces. The forces which do not meet at one point, their lines of action lies in the same plane is known as coplanar non-concurrent forces. This I agree. Do not lie. And this is the forces which do not meet at one point and their line of action do not lie on the same plane is known as the none of this above. The coplanar concurrent forces of those forces whose one point is the lines action of lies the same plane is the do not meet. Coplanar concurrent forces are those forces that meet at one point and their line of action also in the same plane. Non-coplanar concurrent forces are those forces meet at one point, lies action in the same plane. Non-coplanar non-concurrent forces those forces which do not meet one point then the line action in the same plane. Their coplanar forces acting on a point or equilibrium, then the each of for the property proportional of sine at an angle between the other two, right? If shown in the figure, PQ are acting as zero forces are equilibrium, then P by sin alpha equal to Q by sin beta, R by sin alpha. According to Lamy's theory, if three forces acting at a point in equilibrium, they are proportional to the sine of the angle between the other two. Given forces acting on a body, position of a body is kept equilibrium. The effects of produce the internal stress does not change. The three forces acting in represented magnitude and direction of three sides of triangles in the force are equilibrium. Yes. The moment of force is all of the above. The moment of force P shown in the figure, P into OC. The number of coplanar forces acting on equilibrium. The sum of clockwise moments must be sum of anti-clockwise moments about by equal to Wagner's theorem. Moment of states that number of coplanar acting on the plane are equilibrium in the algebraic sum of moments bound to a point is equal to moment of the resultant force of the same point. According to the law of moment, if number of coplanar forces are acting in the particles of the equilibrium, the algebraic sum of the moment any point of the plane is 0. For any system coplanar forces, the condition equilibrium that the all of this above. The force whose lines of action parallel each other and acts the same directions is known as the like parallel forces. 100, 200, 300 is unlike parallel forces. The body is acted upon the number of coplanar non-concurrent forces. It may all of this above. A smooth cylinder lying its convex surface remains in equilibrium unstable. Three forces acting on a rigid body are represented in a magnitude direction. The line of action by the side of triangle taken in order. The force are equivalent couple whose moment is equal to dash twice the area of the triangle. The principle of transferability of force states that the force acted upon body is a fixed minimum fixed center of gravity of the body. A smooth cylinder lying on a neutral equilibrium is the horizontal surface. In three forces acting on a point represent the magnitude and direction of the three sides of triangle. Taken in order, the force shall be equilibrium is true. Two equal and opposite parallel forces, so lines of action different, it replaced by single force parallel to this is incorrect. Two equal and opposite parallel forces whose lines of action different from couple is the right. A couple produces the rotational motion. Which of the following statement discusses all of the above? This is the resultant of two forces P and Q, P greater than Q, acting along the same straight line but in the opposite direction is the B, P minus Q. The resultant of two like parallel forces P and Q is A, P plus Q. The resultant of two equal forces P and Q, P making an angle theta is the D, 2P cos theta by 2. The angle of inclination of the resultant of two forces PQ with the force P, the C, Q sin theta by P plus Q cos theta. The force in string AB due to the load W cosec theta. The force string BC due to the load W cot theta. The point through which the whole weight of the body irrespective of the position is known as the center of gravity. The term centroid is the same center of gravity. Irregular body have the more than the center of gravity. The S. A center of gravity is the rectangular point where the diagonal meet is the agree. The center of gravity of triangular point is the mediates intersect with the true. The center of gravity is an isosceles triangle with base. From the base is the root of 4p square minus q square by 6. The center of gravity an equilateral triangle with each side of the from the three sides is the a by 2 root 3. The center of gravity of semicircular is distance of the from base measured along the vertical radius 4r by 3 pi. The center of gravity hemisphere at the distance 3r by 8 for the measuring along the vertical radius. This is the right. The center of gravity trapezium with parallel sides is the distance of the base shown in the figure h by 3 2a plus b by a plus b. The center of gravity of right circular solid cone in the distance of from which the base measured along with vertical axis is the h by 4. Next, center of rectangular B, it is intersection of the diagonals. Center of triangle, it's E, it intersection of the medians. Center of a circle, it's a center. Center of a hemicircle, this is the 4r by 3 pi along with the vertical radius. Center of a hemisphere, 3r by 8 from along the vertical radius. Center of right circular cone, h by 4 from the base along the vertical axis. The center of gravity of quadrant of a circle lies along center radius distance 0.6 r. The center of gravity T section 100 and this is the okay. This is in the shaded area. The moment of inertia in the dash all of this above. The unit of moment of inertia area is meter power 4. The unit of mass moment of inertia SI units kg meter square. This is the true. A spherical body is symmetrical about its perpendicular according to the Raoult's law. Moment of inertia about to an axis passing through a center of gravity ms by 5. The radius of gyration, the center distance where the whole mass the body assuming counted. This is the correct. Mass moment of inertia is uniform rod mass m length about midpoint of perpendicular length is the 1 by 3 ml square. A mass moment of inertia of a thin rod about its one end and the mass of the inertia same rod at midpoint is the 4 times. The moment of inertia of the rectangular section having the depth about the passing through center of gravity and parallel to the width BDQ by 12. The moment of inertia rectangular section having width depth about the axis passing center of gravity parallel to the depth is the dBQ by 12. The moment of inertia of a square side of about axis through center of gravity is the a power 4 by 12. The moment of inertia of rectangular section 3 meter side formed with the WXX is the 16 centimeter square. The moment of inertia of a square side about x is a power 4 by 3. This is the true. The moment of inertia of a square side of about diagonal is the a power 4 by 12. The moment of inertia of a hollow rectangular section is shown in the BDQ by 12 minus BDQ by 12. The moment of inertia of hollow circular section is shown in the figure. Y axis is not same that the x axis is there. Moment of inertia of circular section is the diameter is the pi to the power of 4 by 64. Moment of inertia of a circular section about axis perpendicular to the section is pi to the power of 4 by 32. The moment of inertia of hollow circular section pi by 64 d power of 4 minus d power of 4. The moment of inertia hollow circular section shown in the figure about perpendicular axis section is the x axis is the 2 times. The moment of inertia triangular section of base height about passing through the center parallel to the base is bh cube by 36. Moment of inertia of triangular section base about through the base is the bh cube by 12. Moment of inertia of triangular section base passing through the vertex parallel to the base, same that passing center parallel to the base is 9 times. According to the parallel axis theorem, the moment of inertia section about the parallel to the axis through the center of gravity Ig plus ah square. The moment of inertia of thin cylindrical mass m radius through the center of gravity perpendicular to the plane disk is mr square by 12. The moment of inertia of thin rod mass m length about an axis through center of gravity perpendicular to its length is ml square by 12. Thank you. Inertia of solid cylinder mass m radius or length of the about length the axis of the power axis is mr square by 2. The moment of inertia of thin spherical shell the mass m radius about the diameter 2mr square by 3. The moment of inertia of sphere mass m radius of about the tangential is the 7mr square by 5. The moment of inertia of a solid sphere of the mass m radius at 2mr square by 5. The moment of inertia of a solid cone, the mass base radius of the circle is the 3mr square by 10. The force acting on the opposite direction of the motion of the body is called force friction. Agree. The maximum friction force which comes into play a body just begins slide over the surface of the body is known as limiting friction. The friction experienced by the body when rest is known as the static friction. The ratio of the static friction to dynamic friction is always greater than 1. The friction is experienced by the body when the motion is known as the dynamic friction. The static friction is all of the above. The static friction is always dynamic friction is greater than. The angle of inclined plane which the body begins to slide down the plane is called the helix angle. This is the fall. The angle which normal reaction makes with resultant is called angle of friction is the agree. The angle of inclination of the plane which body regains to move down the plane is called the angle of friction. The minimum force required the slide body weight of the W rubbing region to place W tan theta. A body will begin to move down the inclined plane. The angle of inclination of the plane, the angle of friction is greater than. A body weight W is the inclined plane, the inclination of the horizontal is alpha. Effort applied parallel to the plane is the P is equal to W sin alpha plus mu cos alpha. Coefficient of friction, the ratio of limiting friction is the normal. Reaction between the two bodies is the S. Coefficient of friction depends upon the nature of the surface only. The force required to the move down the plane, the minimum makes an angle with the inclined plane is the angle of friction is equal to the ladder resisting the smooth ground leaning against the vertical. The force of the friction will act as upward is the upper end. A ladder resting on rough ground and the leaning against smooth vertical while the force of the friction is act as 0 at the upper end. The screw jack is the effort required to the lift of P is equal to W tan of alpha plus pi. In a screw jack, the effort required to lower loads, the effort required raise the same load less than. The efficiency of screw jack is given by tan alpha plus pi. The efficiency of screw jack is maximum when alpha is equal to 45 minus pi by 2. The maximum efficiency of screw jack is 1 minus sin pi by 1 plus pi. The velocity ratio in case of cylindrical plane inclined and horizontal weight of the being pulled in the inclined plane is vertical effort sin theta. An ideal machine is one which efficiency is 100%. The mechanical advantage of lifting machine is the ratio of load lifted to the effort applied. The efficiency of lifting machine is the ratio of all of this above. If the efficiency of lifting machine is kept constant, velocity ratio is proportional to the mechanical advantage directly. In an ideal machine, mechanical advantage the velocity ratio is equal to. In actual machine, mechanical advantage the velocity ratio is less than. The machine having the efficiency less than 50% is known as non-reversible machine. A machine having efficiency of greater than 50% is known as reversible machine. A machine which is the capable doing work reverse direction after the efforts in mode we can't know. This is the fast information. A non-reversible machine is also called self-locking machine is agree. A screw jack used for lifting load is the non-reversible machine. A weight 100 is the 18 the machine is the reversible. A self-locking machine the efficiency must be less than 50%. The law of machine is the P is equal to mw plus c. The maximum mechanical advantage of lifting machine is 1 by m. The maximum efficiency of lifting machine is the 1 by m into IVR. The velocity of ratio of the first system of the pulley is the 2 power of n. The velocity of ratio for the second pulley of the true. The velocity of ratio of the third system of the pulley is the 2 power n minus 1. The velocity ratio, the differential pulley block with diameter d, diameter larger than the smaller pulley is the 2d by d minus d. Which of the following statement is the wrong? The velocity ratio of the machine, the ratio load lifted for the lifted. The velocity ratio of the first system in the pulley with 4 pulleys is 16. Thank you.